So in this video I'm going to explain solution of Codeforces round 915 related for division 2. So in this video I'm going to discuss the solution of first three problems. So let's now begin with problem number A. The name of problem A is constructive problems. So what they have said, initially we will be given a grid, a matrix of n into m size, right? So what they have said, this all the matrix represents the city, right? And these all cities collapse, which means they are not properly built cities. But there is a condition. If there is a city built in the top or the bottom of the side, or there is a city built in the right or left of the city, then we can build the middle city. For example, I will show you the example. For example, if there is a city like this and the city above it is built, let me read different color, and city above it is built and city down it's built among one of these cities, right? And one of these cities which is left or right. If any of these two cities are built, then I can easily build the middle city, right? For example, if my above city is built and my right city is built, then I can build my middle city, right? So this is the condition. Now what they have said, I can freely build a city like this if my condition is true. But if this condition is not true, then the government have to pay funds to that city to rebuild. Now what they're asking us to do, simply tell them what is a minimum number of cities the government should build so that all the cities in my grid are built. And initially all the buildings are collapsed, which means none of them is built. So to tell what is the minimum number of cities the government should add is like this. For example, let the government For example, let the government build all the cities in the diagonal, right? So if government will build this city, this, 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 and this, right? So this is a diagonal which government will build. So if the government build one of the diagonal in my grid, then I can easily build all the cities. For example, in this case, you can see if my these two cities build, then I can easily build this city, right? I can build this, similarly this, and similarly you can see I can fill my all the graph remaining here if my diagonal is filled. So for this example, my my answer is the diagonal, the length of this diagonal. So for all the test case, the answer is length of which is longest diagonal in the answer. So you can see in the 2 by 2 matrix, the diagonal max diagonal is of length 2. In the matrix of length 5 into 7, the max diagonal can be of length 7. So answer is 7. And similarly 3 comma 2, answer is 3. So this is problem number A. So let's now begin with problem number B. So the name of problem B is Beginners Zeldas. So what they have said, we will be given a tree, right? So now what we can do in one operation, I can choose any of the two nodes in my tree and collapse them. For example, in this case, let me tell you how they are saying collapsing, right? So in this case, you can see for example, my graph is like this. There is another pair here, right? So let's suppose I choose a path like this, in which I'm choosing a path like this. This all nodes. I'm choosing a path. So what they've said, by choosing a path, I can combine them in a single path. Okay. So combine them in a single node. So these all nodes will represent a single node. So that node will be like this only. Okay. Now what will be none of the remaining parts? So all the other edges which are coming in between the path, they will be directly attached to this node which we have combined. For example, this node will be like this, and here again you can see these two nodes will be differently placed, for example this and this. So this is my new graph. Now what they have said, how many operation I can perform in this graph so that my graph only contain a single edge. Okay, this is the whole problem. For example, in this you can see I can combine my all the edges like 5 to 1, 5 to 1. The 11 is connected to 1 directly, and the edge here remaining the 6 one. The 6 is directly combining to my 1 comma 5, and my 9 is directly combining to 4 comma 1 comma 5. So this is the problem. So now I have to tell them what is the minimum operation I can do so that my all the tree become a single node. So you can see what is the observation here. So let me draw another graph right here. So let's suppose this is a graph. Okay, so this is a graph. So in a single node, so in a single operation, I will always try to choose a two leaf nodes. So in a single operation, I will always try to choose a two leaf nodes. Okay, So if I to choose two leaf nodes, so now after choosing two leaf nodes, will will these two leaf nodes be remaining? No, absolutely no. None of the leaf nodes from this will be remaining, but there will be another leaf node generated, right? Because you see, if I, for example, in this case, uh, so let's suppose in this case you can see I'm combining 1 to 5. Yes, if I'm combining 1 to 5, then 1 comma 5, this a whole node is also a leaf node. You can see there's no another edge connected to and in the another direction, right? I can consider it, or I can say no also, because you can see three edges are connected. But if only one edge is connected to this node, then when this is not considered to a leaf node. Okay, so this is my observation. In single move, I will choose always two leaf nodes, and after choosing two leaf nodes, my number of leaf nodes will be decreased by -2, right? So for example, in this case, let me choose this leaf node, right? Okay. So if I choose this leaf node, then my single node will be remaining. And what are the other edges? This is a single edge remaining, and I will connect it here only. And to combine these two leaf node, I will choose another operation, this two leaf node. Then this will become a single leaf node. So to make this whole graph a single node, I will choose two operations, right? But what is the observation next, right? Again, that part. What is the observation to find the answer? So what is this? My first observation is like that I will always choose two leaf nodes, and after choosing two leaf nodes, my leaf node will be decreased by 2, and on the remaining part I will again perform the same operation by choosing the next two leaf nodes. So I hope so you are getting the point of view of answer. So simply I will calculate the number of nodes or number of leaf nodes, or I can say number of nodes whose integer is 1. For example, in this case, this is connected to only one node. This is connected to only one node. Similarly, this is connected to only one node. So in this case, you can see my number of leaf nodes are 3, right? So after performing two operations, how many leaf nodes will be remaining? So after performing a single operation, or I can choose after choosing this index and after choosing this index and combining them and combining this path. Okay, my this path is not coming in this path, so I can simply write like this one and another node this one. So my number of leaf node which will be remaining is this only. This is the extra node which is yielded from this, right? But the originally which are the number of leaf node is remaining only one. So by using a single operation, I will decrease it to 1. And what is the number of operation to deal this one? I will simply combine these two both the answers and make it to 0. So you can see my answer is simple. My answer is pretty much simple. First of all, I will calculate all the first of all I will calculate the count of leaf nodes. Okay. Then I will simply find the seal of. I will simply find the count divided by 2, and here it is plus 1. Because you can see if my number of leaf nodes are 3, then my answer is 2. Because you see at the end my single node is always remaining if my number of count is odd. Okay, if my count is remaining, then I have to deal with that also. And to deal with that also, I will use another operation. So that why I'm using a seal function, which means count divided by 2 of seal. Or I will write seal of count divided by 2. So this is my answer for problem number 2. So if I show the implementation, that is also pretty much easy part for this one. I'm only calculating the leaf node. For example, you can see the integer of my leaf node is always equal to 1. So what I am doing here, first of all, I am calculating the leaf node. First of all, I am calculating the integer. Then what I am checking, if my integer is 1, then I will increase my answer. Or I can say increase my leaf count. Here answer is leaf count. Then I will simply print the answer divided by 2 plus 1, or answer plus 1 divided by 2. So that if my number of leaf node 3, I will get the output as 2. But if my number of leaf node is 2, number of leaf node are 4, then answer is always 2, not 3. So this is a problem intuition of this question. So let's now begin the problem number C. The name of problem C is largest subsequence. Okay. So what problem is asking us to do? So let me clear this the board part. Yes. Now it's clear. So what problem is asking us to do simply? We will be given a string of length n. Okay. In a single operation, I can choose a lexicographically largest subsequence of the string, right? And I can perform a cyclic right shift operation on that subsequence. And I would tell them what are the number of operations I can perform such that after some number of operation my string is sorted. So pretty much confusing, or I can say not getting in the first go, right? But this one pretty much easy, trust me. So there's a simple case. If my string is all is sorted by default, then my answer is 0, right? So now let's begin to remember this test case. The test case is A, C, B. So first of all, tell me how I can find the longest increasing longest how I can find the maximum lexicographically largest subsequence in this string, right? So how I can find? So first of all, tell me my lexicographically largest string will always be start with the maximum number of the also start with the maximum character of the string, right? This is a true part, because you can see if I choose like A B C, or I can choose A C B, or like A B, or right C or B, right? Because you see in all of these subsequence my largest is C, not A, not B, because so I will always try to make my first character as largest as possible. So to find the maximum longest lexicographically largest subsequence in this string, I will choose a greedy method. So let me take another example. This is pretty much easy. Or I can say intuitive method, right? So how to deal with this part? So you can see in this case, let me start greedily. For example, I will always choose my last character. Okay, I will always choose my last character, because you see in my lexicographically largest subsequence, in my last subsequence, my first number will always be the largest character in that string. So in the largest character in the string is D, right? So I will choose Z, or I can say Z. So I will choose Z as a first operation. Then I will try to find the maximum. So now I have found that my string will be starting from the this Z, which is the maximum character. Now what I will simply try to maximize the size of this string, right? So to maximize the size, I will start greedily from the left part. So how I can choose the left part? So you can see I will simply choose a 3, right? Now I will see what is the next character greater than or equal to 3, that is E. Okay. So what is the next character greater than or equal to E, which is G, right? So what is the next character greater than or equal to G, which is I, and from I it is M. So you can see but this substring is greater than is always increasing. So I will try to find the increasing subsequence from the right of the array. So C, E, G, I, M. But you see my E is decreasing. So I will not take this part. These are all decreasing. But here you can see I am encountering N, which is greater than N, which is greater than M. So I will choose N here. So by choosing N, you can see I cannot choose E, D, and D, but I can choose Z, right? So I will choose Z here. So by choosing Z, you can see my subsequence will be like this: Z, N, M, I, G, E, C. So this is the lexicographically largest subsequence which I can generate from this string. So what now? So what now? Next, what is the next part? So you can see I can always perform a operation on this substring. For example, you can see by performing a single operation on the substring, what string I will get? I will simply get a C, Z, M, or I can say N, M, I, G, E. So this is the next substring I will get from a single cyclic operation on this substring, right? I will get this part. So what is the next lexicographically largest substring on the whole array, or I can say on the whole substring, so that I can perform an operation? So you can see the remaining part will never play a role. For example, in this case, the remaining part is this. So this part will never play a role in my cyclic shift operation, because you can see my Z is always taken. I am always extracting my Z in the next array. Right, by extracting the Z in the next array, I will always perform operation on this substring which is rendered from the previous one. Okay, so largest what is the lexicographically largest substring in this part? So that is this part only, because you say I will choose greedily. First I will choose E, G, I, M, and Z, right? So in the next operation, what I can do, in my next operation, my this substring, this string will look like, right, E, C, Z, N, MIG, right? So in the next substring, I will choose this, and similarly I can perform operation on this part. So you can see in any other time I can always sort this part, right? Because you see how I'm choosing this array. I'm always picking the elements in the increasing order, which means by performing some n numbers of cycle shift, I can always sort this array. For example, Z is here. So to make to I want to take this maximum character to the end of the array. So I will simply require 1, 2, 3, 4, 5, 6. So I will simply require 6 number of operation to sort this subsequence. So right. So till now I'm only talking about subsequence only. So what will happen to the remaining part, which is colored with blue? For example, in this case, my remaining part is like C, D, D, E, and here it is E, 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 E. So how to deal with this part? So this part is also easy, right? How it is easy? So if it is sorted in its place, for example, this substring is sorted, right? So you can see then my answer can be possible. But there is another case. I will tell you later. So first of all, I will break down the part which I have told you till now. First of all, I will find the maximum lexicographical largest substring by choosing the maximum increasing substring from the last. For example, in this case, I'm choosing this subsequence. So you can see another in some number of operation I can always sort this subsequence, right? So you can see, but there are some remaining elements also which I am never taking. So in this case it is this subsequence. So if this subsequence is sorted, then my answer can exist. But if this subsequence is not sorted in itself, my answer never exists. Okay, but there is also a case. If this is sorted, I can also sort this part. But there is also a case in my answer never exists. For example, let me take another example. Let's suppose I'm giving a substring like A, B, C, D, and here it is like Z, 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 and Z. Okay, so in this case, what I'm trying to achieve is like this. I will simply pick up the whole array. I will simply pick up the whole array. Mm, right. Let me place B here also one more time. Right. So you can see what is the lexicographically largest substring in this part. I will take A, then Z, then this Z, and this Z. Right. So my lexicographically largest subsequence will be like Z, 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 and A. Right. And my remaining part is like B, D, C, B. Right. So you can see uh, my this substring is not sorted in place. Right. So let me make it change it also. Let's suppose here it is like C and here it is like D, right? So now you can see my this is also sorted, right? So what I'm getting a C, B, D, right? So this is my lexicographical largest and this is my remaining part. So you can see I can sort this part. I can use a single operation to sort. In a single operation this would become like A, Z, 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 and Z, and this is sorted in place. But if you can see I can sort this part, so I cannot change the position of these elements. My ABC would be at, at their position also, but my this substring can change the position but in place. I cannot change it any position from the any of the blue part. It will always remaining in the blue part only because I am choosing a simple right cyclic shift. So in a single operation what I can do, I can make it like B, C, and D. And what is this part? This will become A, and here it will become like Z, 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 and another Z. So you can see my this substring is not sorted at all, right? So what I am trying to say is like that. First of all, I will find the maximum largest subsequence in the array or in the string, right? So by finding it, like I will check whether sorting that subsequence, I can say whether sorting these subsequence and putting back in their original position in my string, then checking whether my whole string is sorted or not, then my answer exists, else my answer never exists. So what is the answer in that case? So you can see in this case my string is like that Z, 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 A, B. So let's suppose I'm generating a lexicographical largest subsequence like this. So in this case, how many operations I can perform to sort this subsequence? I will simply find the last index of my maximum character and subtract it from the length of the array. Simply you can see my length of the array is 5 and index of is this 3. So my number of moves will be 2 only. So you can see I can always sort my array in 2 moves if there is some another part that is sorted also. So if I wrap up the whole solution, so what is our solution? So for example, in this you can say I'm taking like this is a small example ZCAB. So you can see in this case what is my what is my lexicographically largest subsequence. That is first I'm choosing A, then first of all I'm choosing like A, then C and then Z. So when that it will become like Z C A. Then I will sort this subsequence. This will become A, C and Z. Then I will place it back here. Then it will become A. This is the previous part and next part is like that A, C, Z. Now I will check whether this string is sorted or not. First of all, I will calculate the lexicographically largest subsequence in my original string. I will find it. Then I will sort it also. Then I will place it back to their position which they have come. Or I can say or their internal cyclic shift. So by performing internal cyclic shift, I can clearly say that this string is sorted in order, right? So this if this string is sorted in order, then what is the answer? So you can see to make this substring sorted, that is my answer. So to make Z come to the last position, what are the number of moves? That is 2 only. So in this case my answer is 2. Or I can say the length of this array which is 3 and the index of my maximum character which is 1. So answer is 2, right? So this is the whole implementation of this question. So you can see in this case my answer is 2. So if I show the code, which is also easy. So first of all, what I'm checking. First of all, I'm finding that this. First of all, I'm finding that this substring, which is the lexicographically largest in my array. Alright. So how I'm finding? I'm taking a maximum minimum character. If my current index is greater than my maximum character, then I will put the index in my differential D array. Right. Simply this D array contains the indexes of those elements which are the part of the lexicography largest substring in my original string. Right. Now next I will simply sort the array. I will simply sort the my lexicographically largest string in place of in my array. So I will sorted that also because you can see if I want to sort this part, then I will simply place the first and second part because this is sorted in reverse order. Because what I'm trying to say is like that I will choose a minimum index, then choose the next greater, then next greater, then next greater. So this substring which it will be generated will always in decreasing order. So to make this in increasing order, I will simply swap the alternative elements from the last, right? So I'm doing this here only. I'm swapping the alternate elements from the swap. So if my if now if now my string becomes sorted, then I will simply print the this part. What is the answer? The answer is the lexicography largest string minus the maximum index of my maximum character. Okay, so this is my answer in this case. Else, if my string is not sorted in this case, then it's simply -1 and return from here only. So this is how problem solution of problem number A, B, and C. So if you have any doubts, you can comment me down. And please don't forget to subscribe my channel. Till let's chat for the next one. Thank you.